Welcome back to the Factory Digitalization podcast. Today, we are going to talk about why all manufacturing companies are inefficient. And we are going to give you a 5-step fix for it. So let's take a look at that 5-step roadmap what takes any factory from data chaos to smart factory. First, I would like to split two definitions: digitization and digitalization. Digitization is converting analog info to digital, for example, scanning papers to computer. And some of the companies think that it's already digitalization, but it's not, because you have to do a lot of manual work even before we get analyzing. Digitalization is when you use digital technology to change the business model. What it means is that you would take the leverage about for data collection, data optimizing, transformation from paper to basically digital solutions to get smarter operations. A lot of factories think that they are digitalized because they have ERP system or they scan some kind of barcodes for some reason they don't even know, but they're all actually making decisions based on the historical data, but they should do it on a real-time data. In manufacturing, digitalization means integrating an IoT and real-time analytics to create a responsive, intelligent factory floor. Step one is data collection and gathering all the data in one place for starting calculations of OE. You can't improve what you don't measure. Let's start from process in manufacturing. If the process altogether is bad or inefficient overall, and you start digitalizing it, you will digitalize the bad process and you have bad process digitalized. But at the same time, you need data to make decisions how to improve your processes because you don't know what's broken and where it's broken. How does Global collect data? There is several options how to do it, and I will briefly introduce them. There's sensors, what are integrated to Scoutbox, what sends data into the cloud, to Global software. And the second option is to use device controllers or machine controllers what are already on the machinery. They can send data via OPC UA or Modbus or something like similar directly to the cloud for the global to analyze. Third option is to use already existing database. Sometimes companies have already some kind of SQL server or something like this where they collect already data. Collaborator can either ask the data from the servers or the server can actually push data to Global inside as well, and it would be visualized and analyzable for the decision makers. And you can also already collect data and feedback from the operators as well. But usually you need to define what to measure. And this is really important because if you measure the wrong things, you will make wrong decisions, you will get wrong results. I'll give you an example where customer wanted to measure pieces. So count every piece of the material what is passing through. But for example, if the machine is, let's say, planing line, where the most important KPI would be meters. And you know that, okay, I had 100 boards went into the machine, but how many meters it was, you don't know because the different kind of boards can be different lengths. Therefore, the result will be biased or not true because let's say on Monday there is you use only 3-meter boards and next day you using 6-meter boards. The pieces count can be more or less the same, but the meters what's supposed to go through the line is totally different. In some lines, it is not possible to measure pieces or meters, but in there you can always measure work time. This is really important in metal manufacturing, where often all the pieces what are made are really custom or the collaborative client based. So the operator went on to, like, say, tens or hundreds of different projects per week. In there, it makes sense that you measure work time, and usually the metal companies are selling their own factory work time to their customers. So they calculate how much time it takes to make one piece of the product. It's a time what is sold to the customer is higher than actually used time for the manufacturing the product, the company earns money. Simple as that. In some cases, it's really important that you record all the environmental conditions, what is happening. For example, in wood industry and let's say food industry as well, it is quite important that the moisture and temperature levels are more or less in the same range because it assures the quality of the product. If it's not achieved, there will be reclamations. For the can give example where customer used our environmental measuring system, and their customer wanted, hey, our product, what I bought from you, it wasn't according as we agreed. The product was painted, and the customer claimed that the wood was too moist, and the paint from the wood just peeled off. Our customer took the measurements of the environmental measuring system, exact time when the product was produced, and you could say our environmental measurements were okay at that time. The moisture was good, the temperature, but also if we promised limits. And in the quality checkups, we can see that the measured moisture of the wood was also the good one. So only thing where the paint peeling could happen is when the board has sunken into some kind of water. That means the moisture of the wood has suddenly increased, and then the peeling starts. And for these reasons, customers say 30,000 euros because of recommendation. To compare what Global can do is that by standard we are measuring pieces, meters per time. With these three, we can handle most of the cases. In some cases, it's needed to measure, let's say, square meters or cubic meters, moisture, water flow, electricity, basically all the different kind of analog sensors used for our system. Global hardware has possibility to use either digital or analog sensors, what are used mainly in manufacturing. Step 2, visibility. In our case, data analytics. Already collected data from the machines, there is no value if it's not analyzed. Our analytics tool give you first step as an understanding of the availability when machine was working, when it wasn't. Second point is notifications, where via SMS or email you can get information what's happening on your manufacturing. I can give you a really good example where I was Global's customer and I used notifications. We had a manufacturing line but supposed to work 24/7. So it was really important that it's always working. When machine was stopped 15 minutes, I set it up like this that the mechanic got an SMS for the phone. If the machine was stopped 30 minutes, foreman got SMS. If it was stopped 1 hour, I got an email. And when it was 2 hours stopped, our CEO got an email. So always the interruption bus escalated to higher levels. So until somebody actually reacts. Thirdly, there is Smart Live View, where you can show all the collected data in TV screens, and it will give you really good chance where there's all these graphs and all the collected data is visible for everybody. So everybody could give you feedback or notice some all the things what is happening with manufacturing without going actually on the manufacturing. So I can give you one good case study where one of our customers, they wanted to purchase manufacturing lines because there was a higher demand in the purchase side, and all the manufacturing capacity in their knowledge is already achieved. So when customer put on a global reader for all of the machines, customer immediately could see that the machines were running roughly 40 to 50% from the work time. After optimizing the workload, after talking with the employees, they could increase the availability to 75%. So within this about 30%, they didn't need to purchase new machinery. They didn't need to invest more money into this already working system. Step 3, is transparency, where you get actual feedback from the shop floor. All correct data is useless kinda when you don't know what is the behind the story. When you just put up sensors and start collecting data, you can see when the machine is working or when it doesn't. But you do need to understand why the machine is not running. And for that, we have operator. One dashboard for everything starts, stops, orders or productions, logs, downtime, quality checks, and so on. So operator can give instant feedback what is actually happening on shop floor. Data needs to reach to the people who can act on it. Shift leaders, maintenance, not just managers who are sitting in the office. For that, we have operator tool what tells you exactly who is doing on what machine, what product, what are the interruptions, and so on. And all this information is gathered from the operators and sent to the analytics tool. Uh, Operator have option to use call for help feature, what means he or she doesn't have to run over the mill and find the foreman or mechanic. They can just write a message and it will be notified for the right person, right time. Thirdly, we have quality checkups. Usually the quality checkups are in factories when I have visited, they are just A4 paper where there's a corrosion and the operator have to fix it. But our quality system is digitalizing this solution and all the information. When actually was the quality checkup done? Are the questions answered? What are the answers? And everything is available in analytics. And it's easy to just export it or analyze it what is actually happening. That means no more paper sheets, no more Excels on the shop floor. This is where the culture starts to shift.
When an operator can see in real time whether they are on track or behind, then managers don't need to breathe down operators' neck. Step 4, predictability, where planning and maintenance meet. Now you know what is happening on the shop floor, but you need to know what's going to happen next. For that, we have a planning tool that helps to gather all the orders in the right order, in right workstation, in at the right time. And we have maintenance that helps to predict and measure when the next maintenance jobs have to be done on the workstation. So you can move from calendar-based maintenance to condition-based maintenance. Avoid failures before they happen. I will give you an example from real life. Usually the cutting saw blades dull about 4,000 meters. You don't know when it's going to happen when you don't measure when the 4,000 meters happens. You need a notification what tells you that, hey, now it's 4,000 meters and you need to change the blades. It helps to reduce the quality issues. It reduces the wear of the machinery and the blades. This is where the condition-based maintenance comes to help. You can assign a 4,000 meter job. So whenever the 4,000 meters happens, the operator or maintenance could have a notification that, hey, this machine needs to be fixed now. Step 5, integration. Become a smart factory. Many of our customers used to have many tools to plan work, analyze what's happening in the manufacturing, usually it was Excel or paper sheets, predict what is going to happen, maintenance some kind of another Excel, and they had to input all the collected data, what was on the papers, to the ERP manually, what created errors in the data input and took a lot of time. What Global Radar Smart Factory solves is that all layers are now working together. Data collection, analytics, real-time operations, you're predicting and planning what is going to happen in next, so everybody knows, and ERP integration, where all the data collected from Global Radar is directly automatically sent to ERP without any manual input. Value for everyone. CEO can see what is actually happening in big business-wise, so all the trends, manufacturing, are they on track or not, are the sales doing their job and so on. So he got good picture of what is happening in his production. CFO gets Real cost, real time cost, understand what is the actually cost per hour, because we measure actual work time, we measure actual costs, and you can put this together. HR can see that maybe one operator is doing better than other, so he can or she can train or plan training for the operators who are not so well doing. Technical managers can stop firefighting because they have planned works, they know where their mechanics are at what time and in what job they're doing, so they have overview how many resources they need. Honest moment, a smart factory isn't problem free. You will still have bottlenecks. You have still supply chain issues and chain challenges, but you will have the data, and this gives you a chance to solve it faster. For example, maybe you could solve an issue by the end of the day instead of by the end of the week. This is a huge gap what you can fill. Manufacturing is under pressure globally. Either it's Baltics, Nordics, Poland, UK, Germany, or you name it place, it doesn't matter. Rising wages, supply chain, distribution, skilled worker shortage, and so on affects all of the companies all over the world. Factories who don't digitalize will lose their margins, delivery times, and talents. The question now is not should we digitalize? It is can we afford not to do it? Globalator offers you a modular approach. You don't need to do it all 5 steps at once. Start with step 1, collect data, understand whether the machine is working or not, and step by step improve your return of investment, and then expand more. So, to recap all 5 steps, you need connectivity, visibility, transparency, predictability, and integrations. Over the next 5 episodes, we are going to go deep on each of these steps. Next up, how to usually get data out of your machines and what OE really tells you. See you next time.